Out Thursday, test is Wednesday. We finish off this unit today and tomorrow. We are looking at rules of differentiation. If you are behind in your work, I apologize. You're gonna have to get caught up. Yeah. So we learned the power rule. That was a good time, huh?
Yeah, I actually love it.
Power rule makes things a lot easier. Today we learned 2 other rules. So if you flip back in your notes, just right above the power rule, we have these general functions here. And today you are going to learn the product rule.
Here we go. Is this less
easy? I wouldn't say it's difficult, but I also want to describe it as easy. We're in calculus now, and I don't think we're going to get to many easy lessons. So it's kind of just the nature of the course. So.
We're going to go with the flow.
Okay. Notice that I derived for you below the power rule. That was a good time. We celebrated that day, right? So if you would like me to, I can derive the product rule for you. I'm not going to lie. It's pretty involved. I was actually sitting in a staff meeting one time that was getting very boring, and I decided to take a hiatus, and I worked through the proof on my own, and it was kind of fun. But I did miss the entire meeting in the process.
Oh.
So,
That's okay.
Yeah. I'm gonna say no. Okay. I was fine with it. So anyway, if you want to see the proof, I can go through it for you. It would take significant amount of time, which you don't have. So come see me on the side. I'll show you that. But the proof. Whoa.
Wait, how long was your meeting?
It was like one of those before school ones, like
30 minutes.
No, like before school started, so it was like one of those
8 hours.
Yeah, you're sitting in the auditorium for 6 hours, and I'm like ready to stab my eye with a spoon type deal.
Maybe that's how I feel every time I sit in surrender.
Product rule: F prime G plus G prime F. So what that means is if you have 2 functions that are being multiplied together, you want to find their derivative. You don't do F prime times G prime. It turns out you take F prime times G alone, and you add it to G prime times F. And that's called the product rule. The quotient rule. Yeah.
Will we get all these rules?
No. Nope. And this is just the beginning. You're going to have a long list of derivatives to memorize. Long list. But you guys are really good at it. I've seen you study for your current events test. You have no problem memorizing massive amounts of material and spitting back out. The nice thing is that unlike many of your classes, you're going to continue to use these throughout the rest of the year. So you'll have purpose behind your memorization.
I agree.
Anybody want to guess what's different for the quotient rule?
You flip it around.
Subtraction.
Yeah, F prime G minus G prime F. All over G squared. Yeah, it's kind of that weird thing.
So it's the same, but it's just minus and then it's over.
Yep.
Okay.
It's the same, but it's not. Very good. Yep. Good. All right, so those are our 2 rules. So now you got 3. You got the power rule. I mean, just think about it for a second. You got a lot of ways to take derivatives, don't you? You know, like limit as x goes to a of f of x minus f of x all over x minus a. Got that piece. You got limit as h goes to 0. Done that. You got the power rule, which we talked about. Now we got the product rule, the quotient rule. All sorts of ways to take derivatives. Yeah.
Does the AP test ever give us like any formulas?
None. I should say that. Suppose it was asking you a complicated question involved, like, say, the volume of a cone. It would probably produce for you the formula for volume of a cone. You know what I mean?
So easy stuff.
1/3 pi r squared h. So it'll produce some of that. But as far as any of the rules, like would it tell you, hey, the derivative of secant is secant times tangent. We're going to tell you that in context problem. Never. No. So. But do you have to pass the AP exam to get credit for this course?
No.
You do not. You do not. Okay? Okay.
Yes.
All right, flip it over. Here we go.
$14.
Flip it to this piece right here.
I love it.
You can only stack 2 of them though.
But then I can go back the next day.
Yeah.
Calculus.
They won't remember.
No, we don't remember.
It's rich. You're like $2 off.
Okay. The first problem, example 2 says differentiate the following functions. Differentiate means to find the derivative. We want to determine f prime of x. I cannot use the power rule because it's not written as a constant times x to some power. It's not written like that. So I can't use that. Okay. So instead, I need to use what rule? The quotient rule, because they're being divided, right?
Mm-hmm.
The quotient rule says I take the derivative of the top, okay, which is 2x.
Wait, so you can use the power rule?
So the power rule within the quotient rule. Okay, so remember it's f prime g minus g prime f all over g squared, where f is the top function and g is the bottom function. That's what we're doing right now. So times the bottom function, which is? So we have f prime times g.
How do you know which one's F and which one's
F is the one on top, G is the one on bottom. So F
Okay.
times x minus 1 minus, what's the derivative of G?
1.
1 times the top. That's all sits over, which is x minus 1 quantity squared. So if you have the opportunity to be able to simplify this, you do. So f prime of x is equal to, I have 2x squared minus 2x minus x squared over x minus 1 quantity squared.
You don't have to factor that out.
We should combine some like terms.
Okay.
2x squared minus x squared is x squared minus 2x over x minus 1 quantity squared.
So we don't like factor out the denominator? Like, do the,
Multiply that out?
yeah.
No, so factoring is not necessarily a form of simplifying unless something reduces in the process. Okay? And that's it. Not too bad, right?
Wait, that's the answer.
That's the answer.
Oh, wow.
So if I did factor out the bottom, would you count it wrong?
Oh.
Okay,
No.
good.
Sometimes you guys ask questions and you sound like this like overly aggressive professor that just wants to take out my red pen. Do I have a history of being overly aggressive on your test with red pen?
No.
Okay, thank you.
Not on Hannah's test.
All
He
right,
doesn't use red pen.
Yes, he does.
Yes, he does.
Okay, cool on.
okay, so let's get the obvious concern out of the way, okay? And because, you know, it's interesting how this is brought up with the product rule and the quotient rule. Isn't it possible that we could just multiply that out, make it a polynomial, and then just do the power rule?
Yeah.
Why not just do that?
That seems like it would be a lot of work, actually.
Yeah, it could take a little bit longer maybe, but honestly, you're never going to see that problem like that and try to do the product rule. It'll all just be written as a polynomial. So the deal is we're trying to teach you the product rule right now to prepare you for what's ahead. So we want you to learn the product rule and the quotient rule now, because where you really use the product rule is when you get this. F of x is equal to, say, x cubed times sine of x. Now, in that situation, you can see that there's no multiplying it out, right? You have two functions. You have x cubed and you have sine of x. So you have to use the product rule that way. But you don't know the derivative of sine right now. We haven't talked about that. You're going to learn next week, Thursday. It's a pretty cool day. Yeah.
Do we get our study guides tomorrow?
Yeah.
Okay.
Yep. So that you have to use the product rule for. So we're still going to practice the product rule. So here we go. F prime of x is equal to, you tell me what to do. Good. Yep, derivative of 2x squared minus 6 is 4x, so I have 4x times 5x squared minus 2x. Okay. Plus, now I need the derivative of that, which is 10x plus 2 times 2x squared minus 6.
Wait, why is it plus 2
Isn't it
times?
-2?
Oh, no, because we're doing product.
I'm sorry, yep, 10x, yeah, sorry about that 10x there. So it shouldn't
Oh,
be,
right there.
yeah, sorry about that. Are we okay with that?
Where'd you get the 2x minus 6 from?
Right there. So this is F and this is G.
Isn't that sort of in the beginning?
So the rule says I take the derivative of that, which is 4x, times that left alone, plus the derivative of that times that left alone. Everybody see it?
Yeah.
Okay, good. All right, we try the next one.
That's the answer.
So let's just, I mean, without a doubt, I mean, could you combine like terms and everything?
Yeah.
Yeah, you could, but what we're trying to practice here is using the rule, okay? Using the rule. And there are a number of times on the AP exam, they don't necessarily ask you to provide the simplified answer. Suppose they wanted to know the derivative at 1. Well, you could just plug in 1 there. You don't have to simplify it to be able to plug in 1, do you? I mean, simplifying would just create more time for you. So on the AP exam, they would say, what is f prime of 1, for example, given this is the function? Well, you would just go ahead and do the product rule and then plug in 1 to evaluate. You wouldn't actually simplify everything. And we'll be getting to that piece coming up here because you'll see what I can be testing you on. Question?
So like when we were in algebra and they're like always simplified, that's no longer the case?
I will be very clear on the test where I expect things to be simplified. But when I'm asking in this very situation to use the product rule, I will not ask you to simplify that expression.
Okay.
Okay? All right. Okay, what rule would you use for letter C? Yeah, use the quotient rule, wouldn't you? Okay, so we have f prime of x is equal to 1/2 times x to the negative 1/2. So that's the derivative of the square root of x minus 1 times the square root of x. Okay? Then I have minus another 1/2 x to the negative 1/2 times
Square root of x minus x.
square root of x minus x. All over the bottom squared, which is just x. So I will not ask you to combine like terms, but I will always require you to make sure you write it with positive exponents, okay? So we won't even simplify the complex fraction here, but please write it with at least positive exponents. So this becomes 1 over 2 roots of x. That's because then if you write it like that, I know that you know how to plug that into your calculator and evaluate it. Question, Hannah.
So the denominator is technically x to the negative 1. Oh, never mind. Hold on, never mind.
You good?
Yep.
Okay. Times the square root of x minus 1 over 2 roots of x times the root of x minus x, and that all sits over x.
How'd you get x over x?
That's from the x bar.
Oh.
Yeah, sorry about that. That x goes right here. We agree that looks pretty tough. So, although you're not going to be doing it right now, I want to show you how, if you were actually truly asked to find that derivative, how you can make it really, 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 really simple. You want to see a simple piece?
Yeah.
Okay. This is a technique that I use all the time. So right now we're asking you to use the quotient rule. But if I were to actually find that derivative, I would not use the quotient rule. What I would do is I would use a technique where I rewrite things using fractions. And come on, I'm struggling here. Okay, so if I rewrite this as f of x is equal to, notice that they're both being divided by what? What do I have in the denominator? The root of x. So I could rewrite this as f of x is equal to the root of x over the root of x minus x over the root of x. So when you have a singular piece in the denominator, you can write each part of the numerator over the denominator, right? So as I have that, what is root of x over root of x? It is 1. And then this is x to the 1 over x to the 1/2. What is x to the 1 over x to the 1/2? What do we do when we are dividing? What do we do the exponents? We subtract and you get x to the 1/2. So that's all the function truly is. And then we could employ the power rule, couldn't we? So you see that the derivative is equal to 0 minus the derivative of that, which would be negative 1 over 2 roots of x. So that just simplifies to that. So this long derivative that you see up here, this piece right there that looks rather cumbersome and ridiculous, it just simplifies right to that. That's it. But on the test, if I ask you to use the power or the quotient rule, I would ask you to do that. Okay. We good?
Yeah.
Okay, flip it over. Nope, don't need to worry about that. I'd like to look at letter F with you. What rule would we use in that situation? The quotient rule. So we have f prime of x is equal to, what is the derivative of the top? 0. That's kind of nice, right? Because you have 0 times the bottom, which is 3x to the 4th plus 2x squared minus x, and you know that that will just disappear, won't it? Yeah. And then it's minus,
Oh, I'm looking at the wrong problem.
and this is important that as we subtract here, notice that the quotient rule again is f prime g minus g prime f all over g squared. I just want you guys to know that you could also do f prime g minus f g prime over g squared. Do you see it's okay to switch those two around because multiplication is commutative? So sometimes I like to put the function on top next, because if I put negative 3 there, notice it turns it to positive 3 times then the derivative of the bottom. And what is the derivative of the bottom? 12x cubed plus 4x minus 1. All right? And that all sits over 3x to the 4th plus 2x squared minus x quantity squared. Okay with that? So obviously I would allow you to leave it like that, but 0 times this is just 0, so you just end up with 3 times that over that. That would be more than sufficient. Does that make sense? Okay, we're going to do one last piece, and I'm going to have you do just a little bit of work in your homework. We're going to pick up the rest tomorrow, just because I don't want to get too confused. These are good to look at tomorrow. These are great problems. Absolutely love them. Glad I made them up. Okay, in this situation, it says find the following. This test to see whether or not you understand how to compute derivatives when you're given an operation between. Notice in this table, and this is what the AP Calculus exam does, is it gives you the rules, which we have up here, meaning the function rules. It says, well, there's a rule. It also includes tables, and it also includes graphs. So we gotta be competent in all three of those. And I would say that, most of the time, people find themselves just competent at the algebraic piece. The table is not very difficult at all. And so it's asking us to determine f minus g prime of 3. And our rule from the other day said we just do f prime of 3 minus g prime of 3. Okay? And using our table, we can then deduce those values. What is f prime of 3? Yeah, you see it's negative 2 minus, and g prime of 3 is negative 1. So negative 2 plus 1 is going to be negative 1. That's my result.
Isn't it 3?
Oh, I'm sorry. Did I make a mistake?
No.
Am I right?
Yeah.
Okay. The next one, I have f prime of 4 plus g prime of 4. What's f prime of 4? I have 1, and I add that to 2, and I get 3.
Where are you getting this number?
So, see how it says f prime of 4? I'm locating 4, and I have f prime. Okay? Now, here's what people do for letter C on the AP exam. They do f prime of 5 times g prime of 5. And that is 100% incorrect. Please do not do that for me on the test. As soon as you see product and quotient, your mind must be brought to the product and quotient rules. And so you know that in this situation, you don't set that up. Rather, what you do is you set up f prime of 5 times g of 5 minus g prime of 5 times f of 5 all over g of 5 quantity squared. Oh, I'm sorry. I just did the quotient rule, didn't I?
Yeah.
Yeah. Emma, I got to get a grip.
Yeah, you do.
Okay, so product rule right there. Looking at our chart, what is f prime of 5?
3.
It is 3. What is g of 5?
0.
It is 0. Plus g prime of 5? 1. And f of 5 is 6. So notice that you grabbed all the values from the location of x is equal to 5, but there were different spots which you grabbed them. And so we get a result of 6. I would like you to do letter D on your own. Obviously, that one you use the quotient rule. Quotient rule. I've got 1/8. What you got? Are we okay? All right, so let's grab our homework. So you see the product and the quotient rule. I would like you to open up to this page. Which says product rule and quotient rule, and has this part in front of you, okay? This part in front of you. And what I would like you to do is look at problem 1A. We're going to do that one together, okay? And it reads x minus 3 times x plus 2. So what we're going to practice in this scenario is finding the derivative two ways. The first way you're going to do it is by using the product rule. Go ahead, find that derivative using the product rule. Please simplify your result, meaning combining like terms and put it into one piece, okay? Try using the product rule for that piece. Yes. Okay, so. This is our first function, which is f. This is our second function, which is g. So if you want to find the derivatives, prime times g, equals g prime times f. Derivative of x minus 3. Slope of x minus 1. 1 to x plus 2. Plus, what's the derivative of x plus 2? Times x minus 3. So if you distribute 1 with x plus 2 plus x plus 3, 2x minus 2. Okay, let's check to see what you have. I call this f, I call this g. What is the derivative of x minus 3? It is 1 times x plus 2 plus, and the derivative of x plus 2 is 1 times x minus 3, okay? And notice you get x plus 2 plus x minus 3, and so your derivative is 2x minus 1. Okay, that's equal to f prime of x. The second way I want you to do it is instead of taking the derivative using the product rule, I want you to actually multiply these out. Go ahead, multiply them out, FOIL it out, and then take the derivative. See if they match. FOIL it out, take the derivative, see if they match. Okay, as you multiplied it out, you should get x squared, you should get a minus x and a minus 6. We have not taken the derivative yet. That's just what the function is equal to. If you take the derivative of x squared is 2x, and the derivative of negative x is negative 1. So those should match. Everybody see that? So that's what you're able to do for letter B, and then for number 2. If you want to continue to work tonight, I just want to point you in this lesson. Don't do problems 3 and 4 till tomorrow. Don't do problems 3 and 4 till tomorrow. Section 5 is a review of some of our derivatives. I put that there a couple years ago because this is where people were making mistakes on the test. These type of problems that you see for section 5, those were the problems that people were getting wrong. So I would highly encourage you to give those some good attention. And then the back side, if you look at, there's 2 problem 6s, sorry I didn't delineate there. The top one that involves a table, that's something that you can work on as well. So, but problem 3 and 4, and then the second 6 one, that's something that we definitely want to leave till tomorrow. So we've got about 10 minutes. Tomorrow's lesson is going to be very short. It's only going to take us about 10 minutes, and then you're going to have the rest of the time to work. I promise I will get to your study guide. So, how does this work? So the derivative is
Then what happened over here?
6x plus 1 times x times the bottom, not the derivative of the bottom. See that?
And then.
Yeah. I'll show you the beginning of it.
Okay.
What's that?
Yes.
Okay, so we're good. So it's 6x plus 4 times x. So you get 6x squared plus x
He's here
minus
today.
3x
He's
squared
not here for my class.
Why?
minus
He has
x
cross country.
Well, then I
over
don't.
x squared. No, x is canceled.
Oh.
6x squared minus 3x squared is 3x
Oh, we
squared
still have
over
to do our
x
partner
squared.
thing, I'm
So
on our
those
partner
cancel.
go.
Yeah, that's what we're doing today.
So that's the product rule, but you also want to write it as a polynomial.
So you just.
So if you write it as a polynomial, because we just divide the x off,
But I didn't get the same thing down.
and you get f of x is equal to 3x plus.
Oh, never mind, yeah, I do.
And what's the derivative of that? So you can see the yes. Yeah, we sure can. So in this situation, we would have 2x minus 5. On the bottom, I'm gonna write this as 2x to the negative 1, because it's 2 over x. So that's minus 1. So in our derivative, we take the derivative of the top, which is, I'm sorry, minus x, yeah.
Is this right?
So what's the derivative of the top? 2 times 2 over x minus x minus, and then we have the derivative of the bottom. And 2 over x squared, which is subtract 1, minus 1,
Yeah.
times the top,
I'm guessing so. See.
over 2 over x minus x.
So we're gonna use that.
Yeah, I mean, it's the same thing, I just chose to not write as a negative exponent. I wrote this one as a negative exponent so that we can see that.
Mr. Gans, can I go to the bathroom?
Yes.
My pee hall pass isn't working.
Okay. I'm not gonna make us try to simplify that. Alex, be 1 second.
Wait, I didn't get the.
I can't do it, like, I watch service.
Hey, we're trying to do better.
Oh, my goodness.
Aaron, yours are so Alex.
I was at
I don't know what
Mine
happened.
were like 33 cents.
Yeah.
So,
Actually.
yes. Well, they weren't 30, they were like $1.
I understand why they were doing
Yes.
this.
And my mom,
I never know how far out that I need to go, you know?
I'm thinking I missed something on the.
Just like you can find like.
This is what I got at work for the first.
Like that.
That very well might be the answer. So we're gonna check by, just distributing. If we just distribute this, we get 3x to the 4th, and we get a minus 3x to the 9th. Don't.
That's true.
And so if we take this derivative then, so the derivative should be 12x cubed. Once you have that,
That's true.
minus 27x to the 8th.
We'll see.
And then, okay.
So it looks like your negative 12 x to the 8th minus 15 x to the 8th, that does come out to be negative 27 x to the 8th.
Perfect.
So that would work out. See that now?
Yep, missed the 9.
So you gotta move X and
All of my socks, so it's only the left one.
to be able to take the power.
And apparently, there's something.
Yeah, so you're really close here, okay? So you get a factor of 4 on the top,
So I had from,
okay?
yeah.
You get
That makes
x
more
plus
sense.
1.
And then I had these that I had from lunch.
And on the
I never
bottom,
wanted because they're awful.
X squared plus 2x plus 1 is the same as x plus 1
And all of a sudden,
on a
this is what
squared,
I had.
right?
I also have something.
That factors in x plus 1 times x plus 1.
I was gonna say, they also didn't know.
So it's x plus 1
Forgot
squared,
about it. I'm sure it's not like.
right?
Yeah.
You have 4 of them, so the slope is
But I ran.
4 times x
I walked
plus
like
1
from my
over x plus 1 to the
Yeah, I can see it.
4th power.
If you take,
I said I
I
was.
just got 3.
There's one on the top, so
And then go on the bottom, so you get 4 over x plus 1.
Yeah.
that makes sense.
Better?
They're definitely not totally different, they're the same sizes.
And also, I don't know why I couldn't remember the power.
I was definitely not too lazy to monitor.
What do you,
So these are the last 2 socks.
do you get raised?
Yeah, so, when you multiply the 1/2 in front, you get a 2, and you subtract 1 from there, so you get negative 1/2, yes.
Oh, we have minus X over
Five
here.
socks, that's bad. I have all of the exact same
The X
sizes.
is canceled out.
Obviously, you're the one.
I got a negative 3.
Yep.
So you got a negative 3. Oh, because it's.
You can do it.
Oh, never mind. Yeah, okay, now it works, okay.
There she is. Yes.
Why does one do that? Whenever she would come back, I'm like, focus on
It's like chars,
Yeah, it's so fun, you really have charcoal.
with like grilled.
I don't have them. Like they're full of.
I got 46 over 25.
Oh,
I got this answer key right here. Should be accessible online as well. If you don't see something online or something's not available, please send me a message and I'll try to unlock permissions. I'm not sure why it acted the way that it did 1, 2.
There was a mistake. So, so, alright, so this is 0, right?
No.
That one goes there.
Nope. So you can't take the derivative at that spot. Because it's a corner. Yep, so there's no derivative there. So when we look at this graph of the absolute value of x,
You get negative 3 squared.
we see that the derivative here is negative. But it isn't just negative, it's an exact value of -1. So the derivative here is always -1. So that means the graph of the derivative is going to be a line that is constantly at a height of -1. This is that part of the graph of the derivative. So that is the first piece of this distinction. You see that that is just that. If I point here, what's the slope? So therefore, this has a height of -1. If I point here, what's the slope? See, this has a height of -1. Your slope is always -1. What's the slope here? positive. Okay. No matter where you go, it's always a positive one.
I did this, but then he got that. Oh, I see what you did. You did, you just did X one, so 2 minus 5 is -3, 1 minus 5 is -4. So you're going to do that.
So this
Yeah,
is.
because this one you did down here too.
Okay, I'm there.
I don't know if you said
Oh, yeah.
Always in the group chat. I don't think
I have, I don't even know if that group chat's work.
it's for the senior.
Okay, I have Hannah Barclay.
It doesn't start till like.
I think so, yeah. Yeah, and then I have Henry. So I'm guessing the other person's Landon.
No, it's not.
Probably. But what about
It's not
Mary?
very heavy.
Who
is it?
Oh, it's I'm just trying to figure out. They're like, I don't know, we didn't win last year. I know that was our first game last year.
I'll just text her privately, be like, look, he's.
I know we didn't win. I remember them sometimes, but so like golf, you can probably name like all the good ones. Like, see for like volleyball, I can name most of them. So like, oh, which one is the one that it's like the higher, it's like higher, it's like good, but it's
Hannah,
not
you were
like
so
unbelievably good, like I don't
I took all of my Riverland work for 3 days.
Wow. So here's where it starts a little bit. Is you have the limit as h goes to 0 of, and because it's f times, right? It's f of x times g of x. What you end up with is f of x plus h times g of x plus h minus f of x times g of x all over h. And so the key in this scenario is to try to gather the like things together. So we would like this thing to be paired with that thing, and we would like that thing to be paired with that thing. And so we can start to rearrange terms accordingly and to try to do that. There's a little bit of a tricky business that happens in that rearrangement though. Because, you know, there's not necessarily anything to say factor out right now or anything like that. But we can multiply by something to gain the things we want in the top, and then the bottom works out kind of nice. Whereas with the quotient rule, when we multiply this thing up there, the top works out nice, but we end up with a conglomerate of stuff that comes in the bottom, which is why you get the g squared. So it starts here, so you do start setting this up, just like the rule says. But in order to begin to rearrange, you end up creating multiple limits is what you do. You divide them up into 2 limits using subtraction. And but you gotta find the right thing to multiply to. And that's the tricky business. So it took me a while to figure out what I multiplied by, but
you just like figured it out.
that one I did. So that one I was feeling pretty good. I was like, I'm gonna try this one without looking at the proof. Wow. Now, to be clear, I've seen other examples, not of the product rule, but I've seen that strategy.
Why do you look like that?
There are some where I remember test one time.
other pictures? Yeah. I don't know for the ones you read though, like the ones I posted.
Nobody got it, so I always look back.
Yeah.
And I worked that for 10 hours. And when I looked up the way that the solutions derived, sure enough,
Chicken run through the screen and
they
really fast.
used multiply model. And I was like, but when you see it, you're like, oh. So there are some of those strategies, and if you have enough time to memorize, you can practice them. Yeah, it's kind of tricky. But I'll show you the whole piece.
Yes. Here, let me see my swing.
Bye, Chica.
The big bass. The big am.
I thought it was great, actually. Good, great. You can look at Whitney Houston.
That's by far way to
117.75 with the $9.
She's ready to go. She's taking care of her business.
What
What up, Jog?
Great.
Oh,
sorry?
On the street.
Do I know how to make a circle?
No, I mean like, race. Like, smart work.
Oh, show me.
No, it's now.
Oh, I can lasso it.
Hold on.
Oh, cool. So I lasso. Oh, I like it. Cool. Cool. Who'd you see that from? Cool. Nice. I'll have to-
Miss Kiesler learned how to freeze it.
Okay, cool. I like
Glad
it.
they are.
So Ethan taught us how to get rid of things in a group. So instead of grab the eraser, you could grab the lasso, and then it will say, was that trash?
Yeah.
Boom. Wow.
Wow.
I didn't know. It's kind of fun. I like it. So what do we got going on? We got volleyball tonight.
Yeah.
Smacking the volleyball around against
It's
the
a
dirty
Huskies.
sewer dogs of Owatonna.
Ew!
Ooh, nobody likes the sewer dogs of Owatonna. We are also swimming against the sewer dogs of Owatonna tonight. And the cross country team is running against the sewer dogs of Owatonna.
It's water.
And soccer is playing against Owatonna. It's like Owatonna Thursday. I hope you beat every single one of them. I hope you do.
Thanks,
You ever smacked the ball so hard it broke somebody's nose?
No,
but I have hit people in the face
before.
Alright, does that feel good?
I feel bad for him, but I mean, it's the game, so.
She feels bad. What happened to this one?
She's sick.
She's sick. Yesterday she was all bouncy and cheery and ready to go, and now she's just sick? I don't accept that.
I'll let her know.
Come on in. This is a happy class. We all smile, laugh.
It's just pretend though.
Oh, wow, look at that, Do you want to take your test here? You'll hear me talk, or do you want to take it sitting out there?
Can I take it out here?
Sure thing. Why don't you sit down out there and I'll get you ready to go, okay?
Thank you.
All right, true or false, do you have any tests next week?
False.
All right, way to go. You know your schedule. Your test is the following week. Good job. So got some things to get through tomorrow. You have time we'll do a checkpoint, and you're going to have time to work on homework and ask questions. I'm kind of giving that day because you guys have had your historical society stuff, historical museum, society, museum, which is it? Okay, so you're not part of a society yet.
Okay.
You ever watch the Office? Finer
Big
Things
nose
Club, Finer
and
Things
this,
Society?
yeah.
Yeah, that would be, we should create our own little societies. So,
Maybe the pre-calc society.
yeah, so we are gonna do kind of this is a review lesson today, and then it gets a more challenging on Monday. Not too challenging, but a little bit more challenging, but we're gonna start with that 2.5 pair function. So take that out, try to make sure you got plenty of time to ask questions and stuff. The dudes. Okay, buddy, ready to go?
Did you know that you've never said
I'd be lying. They snatched.
no?
I would say that I like your shoes, but I genuinely dislike them. What else can I say? I would say that you look.
How about Bryant? How about Bryant doing some music on the pause today?
Yeah.
I didn't even get to watch it.
We never watch football. You're gonna have, if you want to watch football.
Yeah, you can mention.
Thanks, date made.
You guys watch football. You can just listen to the ball.
This is you. Exactly. See, I roasted you.
I don't play percussion. I play the saxophone. That was not a roast. I would love to be a genius like
No, I'm not saying there's anything wrong with being accent. I'm saying that you are not a male. What is it? 2.1?
I didn't see you.
What is it?
Game day.
Oh, were you sitting on her, or was she sitting on you? I don't typically like it when people just sit on each other. It makes me feel like
Well, like, yeah, it's a trick.